Now we're at the second half of the
Problem
lesson
number 6.
on mechanics of materials.
For the beam shown,
what
what is the maximum
and we're going to solve some
compressive
problems
stress
now
at section
on beams and
DD,
columns, typical of the
which we
problems
will
that you would
sketch
see
in here,
on the FE exam.
section DD, and that should read 1.5 meters from the left end. 1.5 meters from the left end is where section DD is. Okay, this is a simple problem. We have just the one force, the 45 kilonewton force, and we need to proceed in the usual way. We need to find the reaction force at A. So in order to get the reaction force, we'll write a summation of moments about C, which should be equal to 0. Well, if we have a reaction force like this, call it R sub A, we can say that R sub A multiplied by a moment arm of 1.5 plus 3, which is 4, must be equal to the 45 kilonewtons acting at 1.5. So this tells us then that R sub A must be equal to 15 kilonewtons. If the reaction force is 15 kilonewtons over here, and we're interested in what's happening at this section, then as we move from left to right, the only force that comes into play here is this reactive force of 15 kilonewtons. So what we end up seeing is that the bending moment at this section DD, which is 1.5 meters over, that bending moment will be equal to 15 kilonewtons times 1.5, that's going to be the moment arm here, 1.5 meters. That gives us 22.5 kilonewton meters. That would be the bending moment at section DD. Now, to get the maximum compressive stress, which will be at the top fiber of the beam section, we need to do this way. Sigma max is equal to MC divided by I. Well, here's the value of M. We already found that to be 22.5 times 10 to the third Newton meters. C, this distance C now we go back to the problem statement and you find that in the geometry, looking at the cross section of this, we have something that looks, it's rectangular, it's 10 centimeters, or maybe we should call it 0.1 meter, and this way it's 0.125 meters. So if I put the neutral axis through here, we can see that the value of C is 0.05. So C is 0.05 meters. To get the inertia, I need to use the formula 1 over 12 times BH cubed. The B in this case is equal to 0.125 going this way. The height is equal to 0.1, so I take 0.1 and this is cubed and this is divided by 12, and that's the value of inertia goes in here. So if I take all these numbers together, I would find that sigma max is equal to 108 MPa. It's a fairly simple problem. Just remember the strategy. In most of these problems, you should start off by identifying what the reactive forces are, and then just move from left to right with the shear diagram, and you'll be able to work the problem very easily. You have to watch for the computation of inertia, but most of the cross sections that they give you in the exam are simple like this, so it doesn't require much more than BH cubed over 12. Remember, this is the B dimension, this is the H dimension.